In section 2, we are looking at how they discovered the structure of the DNA molecule. So DNA is composed of 4 different types of nucleotides. So these, the nucleotides, once again, are the monomer that make up DNA. And they arrange themselves in long chains. Each nucleotide has 3 parts to it. It has a phosphate group, a deoxyribose sugar, which is a 5-carbon sugar, and a nitrogenous base, or a nitrogen-containing base. So here's your phosphate group, here's the 5-carbon sugar, and then here is the nitrogen-containing base. And there's really 4 different types of these nucleotides, like it says up there at the top. So the nitrogen-containing base are the only difference in those 4 nucleotides. So you have the 4 nucleotides are thymine, which a lot of times is represented as a T, adenine, which is represented as an A, cytosine, which is usually done as a C, and guanine, which is usually done as a G. So the thymine and cytosine are what are known as pyrimidines, and the adenine and guanine are purines. So the people that put together the 3D model of DNA were Watson and Crick. They realized that the DNA was a double helix that is made of sugar and a phosphate backbone on the outside, with the bases making the rungs of the ladder. So there's an image of what they looked like and what their model looked like. Now it sounds all well and good that, oh yes, they were the ones who did this, but they really stole the work from many other people. So the people that they got the work from was Rosalind Franklin and Erwin Chargaff. And Rosalind Franklin, she was doing X-ray crystallography, basically shooting X-rays at crystallized DNA and taking pictures of it. And her image that she had done was what Watson and Crick actually got a lot of their measurements to build their model off of. And she didn't really give them permission to have the picture. You ended up having Watson, you had one of them end up taking the image. They got it from one of her, who was above her at the university. They gave it to them without her permission, and they were able to get the measurements that they needed to realize that it was a double helix. What they ended up getting from Chargaff was he did research on looking at how many nucleotides were in different organisms, and he found that adenine was always in about the same amount as thymine, and cytosine was always about the same amount as guanine. And so he ended up coming up with a rule that is A equals T and C equals G. This idea is what we refer to now as base pairing. So in that image right there is Rosalind Franklin and the picture that Watson and Crick had obtained. So with the nucleotides, like I said, the base pairing rule shows how the nucleotides always pair up in the DNA. So A pairs with T, C pairs with G. Because a pyrimidine is a single ring, it pairs with a purine, which is a double ring. The helix then has a uniform width the whole way up. You're not going to see like a bulge here or things like that. It's going to stay the same all the way through. So the backbone is connected by covalent bonds. The bases are connected by hydrogen bonds. So in between the two sides of the ladder, the rungs are going to be connected by hydrogen bonds holding it all together. That makes it easy to unzip when it needs to copy, and it's going to hold it together pretty well for the most part. So that is the end of the notes for section 2.